In this video, we're going to be covering the 11.3 worksheet. Number 1 says the first three terms of a geometric sequence is -2, 10, and -50. Find the next two terms. So the first thing we need to do is go ahead and find the ratio. I took the middle term, which is 10, divided by the previous term by -2, and that gave me a ratio of -5. Then I took the last term, which was -50, and I multiplied by the ratio of -5, giving me a 250 for our fourth term. The fifth term is the 250 times the -5 again, and that gave me an answer of -1250. So this is the next two terms in the sequence. Okay. Number 2 says identify if it is an arithmetic or geometric sequence. So the very first part, I went ahead and looked at the second term and looked at the first term, and I can see that we're adding a difference of 5. From the second term to the third, we're also adding 5, and I did it one more time. From term 3 to term 4, we're adding 5, so this is definitely an arithmetic sequence. Okay. For number 2, if you can look, you can definitely see that this is not subtracting by a common difference, so it's definitely not arithmetic. In order to check if it's a geometric, I took the second term, which is 300, divided by the first term, which was 3,000. That gave me a ratio of 1/10. Then I did it again over here, and I took the 3 and I took this 10 here, and I also found a ratio of 1/10. So in this second part, it is a geometric sequence. Okay. For number 3, you can see that this is definitely not going to be an arithmetic because it is going from 2 to 1 and then from 1 to 2. So it's not arithmetic. Let's check if it's geometric. I took the second term, which was 1, divided by the previous, which gave me a ratio 1/2. Then I took the third term, which was 1, divided by the second term, which is also 1, which gave me a ratio of 1. This is not geometric because the two R's don't match, so this is going to be a neither case. For number 3, it says identify the geometric sequence and then find the common ratio. Okay. First thing we did was go to the second term. I had 14. And I divided by the 7, I found that to be 2. 28 divided by 14, that's also 2, so this is geometric, and the ratio is going to be 2. For the second question, I went ahead and did -40, which is here, divided by 80, the previous term, and I got a -1/2. Then I went over to the 20, divided it by the previous term, which was -40. I also got a ratio of -1/2. So it is geometric, and the ratio is -1/2. Okay. For the third part, I can see going from 4 to 6, I'm adding 2. From 6 to 8, I'm also adding 2. This is not a geometric sequence because you have a common difference. So I just put here, not geometric. Number 4 says to find the 13th term of the following geometric sequence. First thing I'm going to do is go ahead and solve for my ratio. I took term 2 divided by term 1. So 15 divided by 5 is going to be a ratio of 3. I'm going to confirm that by taking 45 divided by 15. I also get a ratio of 3. My first term is a of 1 is equal to 5 because that's the first one that's given. I use the general equation found on your formula sheet for geometric sequence. It's located here. So I just rewrote it, and then I substituted. A of 1 is equal to 5. Our R is equal to 3. And N, which is 13, is going to be 13 minus 1, so it's raised to the 12th power. Plug this into the calculator, and this is the answer you'll get. Number 5 says to find the 7th term of the geometric sequence whose ratio is 2/3 and whose first term is actually 3. So R is equal to 2/3, A of 1 is equal to 3, N is going to be 7 because that's the term that you're looking for. Again, use that formula that was given on your formula sheet, and let's go ahead and substitute. A of 7 is equal to A of 1, which is 3. The ratio is 2/3 raised to the n minus 1. Since n is 7, we're raising this to 7 minus 1, or in other words, 6. Plug this into your calculator and you'll get a ratio of 64 divided by 243. Okay. Number 6 says, for the given geometric sequence, the common ratio r is 2. So I put r is equal to 2 here. The seventh term, denoted as a seventh, is equal to negative 23. So I wrote a of 7 is equal to negative 23 here. Find the value of the 10th term. So what we're looking for is a of 10. In other words, n is going to be equal to 10. Okay. First thing I'm going to go ahead and do is use this formula. Okay. This formula is a manipulation of the formula we have here. Let me show you how. Okay. A of 1, this 1 matches this 1. This n matches this variable n here. All I did was replace the a of 1 and the 1 with another variable I called m. So here you have an m and here you have an m. This is like saying 1 and here's like saying 1. It matches the formula. Okay. Alright, next thing I went ahead and did is I went a of 10, which is what I'm looking for, is equal to a of m. I'm going to go ahead and let my a of 7 be our a of m. So here I put negative 23, r, which is 2, n minus m, which is 10 minus 7. Okay, simplified it here. Negative 23 comes straight down. And then all I did here was do 2 to the 3rd power, which is 8. Multiply these two, and you get a of 10 is equal to negative 184. Okay, number 7 is a two-part question. It asks us to compute the sum below and write the answer as a fraction if needed. Okay, so the first one, you notice on here we have a final term. So let's go ahead and solve for that one. So our first term is going to be a, which is 2. N is going to be, this is going to be to the first power. So that's 1, 2, 3, all the way to 5. So n is going to be equal to 5. Okay. Be careful. If this was a 0, you would actually have 6 terms here instead of 5. Then I'm going to go ahead and look at our ratio. Our ratio here, if you can see, we're multiplying from the first term to the second term, we're multiplying by 2. So r is going to be equal to 2. Okay. Next thing I did was use the formula from the formula sheet. I've written it here, but it's also right here. Remember, this is for arithmetic, this is for geometric. So I just rewrote it here. Plug in your values. A of 1 is 2. 1 minus r, which is 2, raised to the nth power, which is going to be 5. All divided by 1 minus r, which is 2. Put this in the calculator. Remember, when you're putting this in the calculator, make sure to include parentheses in the numerator and in the denominator as well. I went ahead and just did the part in the parentheses first. So 1 minus 2 to the 5th is negative 31. Multiply that by 2 and divide everything by negative 1. You should get an answer of the summation of the first 5 terms is going to be equal to 62. For part B, it's given in a little bit slightly different notation. Here you know it's a summation because you have the summation symbol. Okay. First thing we need to do is go ahead and determine what our first few terms are going to be. Okay. So I plugged in a 1 for my k, which is here. So 3 times negative 1/4 is going to be negative 3/4. That's going to be my a of 1. Plug in a 2 here, and I get 3 times 1 over 16. So that will be my second term, 3 over 16. Okay. A of 3, I plug in a 3 here, and I'm getting 3 times negative 1 over 64. Okay, so I have that right here. Once I have my first three terms, I'm able to determine my ratio. I started with the 3/16, which I have here. I didn't divide in this case because I knew that I would have a complex fraction. So what I ended up doing was flipping it. So the first term stays the same. You change the sign from division to multiplication, and then you flip the previous term, which is this one. So I flipped it here. Multiply across, or here what I ended up doing was simplifying. 3 goes into 3. Negative gets carried over. 4 goes into the 16 4 times, so our ratio is going to be -1/4. Okay, so the first thing I did was plug in my a of 1, which ended up being -3/4, that's my a of 1 here, times 1 minus r, so 1 minus r, which is -1/4, raised to the nth power. N is going to be 7 because we're looking at the summation form, which is right here. This is going to be our n, which is 7. So I plugged in a 7 for that one. All divided by 1 minus r, or 1 minus -1/4. Okay. Make sure to include parentheses in the numerator and in the denominator. I ended up doing all the math here. Sometimes your calculator cannot convert back into a fraction, so sometimes we have to do the work, show your work as you go. So that's what I ended up doing here. First thing I did was bring down my -3/4, and then I kept my 1 here. A negative to an odd power will be a negative, and a negative times a negative is a positive. Right here, all I did was apply the 7 to both the numerator and the denominator. So 1 to the 7th power stayed as a 1. 4 to the 7th power is going to be 16,384, and I have that here. Okay. Now, what I did in this part is, remember, this is going to be a 1 over 16,384, but I'm adding it to 1. So if I change this to a ratio of 1 with this denominator, all I'm doing is adding 1 to the numerator. So when I do that, I get a 5 at the top, and I still stay with the 4 at the bottom. All of that times -3/4. Okay? Down here, you just add these two together, and you should get 5/4. So here's my complex fraction. What I ended up doing was doing this all stays the same, so -3/4, there's the same fraction. Change the sign from division to multiplication, and then flip the denominator. The 4's cancel out here. 5 can go into this number this many times, and now all I have to do is multiply these two together. So -3 times 3,277 ended up being -9,831, and then I carried the denominator over. Okay. This will be your final answer. Number 8. Number 8 has two parts, and it says compute the sums below. Okay, give the exact values. Do not use decimal approximation. If it does not exist, state no sum. The very first one, I started with the a of 1, which was -1/3, which is located here. Okay, if you notice, you're multiplying it also by a -1/3, so our ratio will also be a -1/3. Since this has a 3 dots here, I know that it's a infinite geometric series, so I'm using that equation that is listed right here. Notice that all you need is a of 1 and an r to solve. So I have s is equal to a of 1, which is -1/3, divided by 1 minus r. Here's my 1. Since r is negative, it's negative times negative gave me a +1/3 here. Okay, I went ahead and simplified. This is going to be -1/3 in the numerator. 1 plus 1/3 comes out to 4/3. So I did the stay. First numerator stays the same. Change the sign from division to multiplication, and then I flip this one. The 3's cancel out, so my summation comes out to -1/4. Okay. For part B, it looks a little bit different. I know that this is an infinite sequence because I have an infinity sign where n is going to be. The first thing I want to do is go ahead and find my first 3 terms. So I'm going to plug in a 1 for my k. A of 1 will be equal to 2/3. K is equal to 2. I'm going to square everything in the parentheses. So I will get 4/9 for A of 2. When K is equal to 3, everything is cubed. So 2 cubed is 8, and then 3 cubed is 27. So I have my first 3 terms. This helps me determine my ratio. I went ahead and got my second term, which was 4/9, and I did the times, and then I flipped it. So it'll be times 3/2. This is to prevent me from getting a complex fraction. Okay. Then I went ahead and reduced. 2 can go into 4 2 times, and the 3 can go into the 9 3 times. So I get 2/3 is my ratio. Once I have that, all I need is my ratio, and I need my A of 1. So A of 1 is going to be 2/3, which is in the numerator, divided by 1 minus r, so 1 minus 2/3. Okay. Here's my complex fraction, and then here's where I changed it to avoid the complex fractions. 2/3, change your sign from division to multiplication, and then flip your numbers. You see the 3's cancel out, so the summation is equal to 2. All right, that concludes this worksheet. Let me know if you have any questions.